whatever this is. We are going to pick up right where we left off last week. After I do the few announcements, although they're already on Blackboard, so you should know most of these. Now, I finished grading assignment 1. Fight me if you want to argue about your grade. You're welcome to argue with me about your grade. Whether you're going to win or not, we'll see. But assignment 1 is done and graded. Assignment 2, and actually there's a slot in here. There's a gap. Anyways, assignment 2 is being issued tonight, just so you know. And it's going to be due December 19th. Test 2 is issued to you next week. Also 2. Which is why I sent out an announcement earlier, like Sunday, to warn you guys. And it's going to be due the 19th. So you got a week. It's not done in class. It's take home. You got a week. Open book. Same thing as test 1. It covers the chapters as listed on the CSI. It's the same chapters that were listed on the CSI, so they're right there. And the practical test, can't use the word exam, even though it's the exact same thing, will be the week of January 8th to 11th. So the last week of school, right before you go into your next term, you get to do this last test. That one will be done with you guys, I'm guessing, right here in this class. I don't see the point of getting Cheryl to do it. Therefore, I'll get you guys to do it with me. That way you're getting it right from the horse's mouth if you're not sure about what the questions are. Makes it easier for you guys. My other group, I can't do that. The group's too big. Okay. All right. That's the announcements for today. Now, the list of chapters that are there, the list looks long. Some of these chapters aren't that long. And literally, like, Chapter 19, I think it's 5 pages of Chapter 19 or 4 pages of Chapter 19. You don't need to memorize it. You just have to know what's in it so you can find the answers in applicable places in the chapter. So review these chapters, do the test. Test is getting released next week, so I'm giving you guys a whole week to catch up on the reading that you had 5 weeks to do and probably didn't do. Just putting the thought out there. And yeah, so that's the announcements there. So this week I'm picking up right where I left off last week. The topics I'm covering are going to be aggregates. I'm going to cover joins in more detail. Because you guys are a little bit offset from the other group, because the other group I had to rush ahead a little bit, so I'm a little bit offset from each other. Yeah, for you guys, it's more details on the joins and the aggregates. Time permitting, I'm going to do subqueries and set operations. We'll see how long this takes today. And that's the last of the SQL language that we're covering, so I don't want to necessarily finish it all off today. But I'm going to start with aggregates before I go back to joins. And aggregates are used specifically for calculating stuff out of your database. So aggregates are used for counting, for sums, to find out the biggest and the smallest values. Essentially, if you've ever used a spreadsheet and used any of the summary functions in a spreadsheet, it's the same thing, except you're controlling programmatically what gets grabbed and from where. And the pieces are as follows in it. There's a few different pieces in an aggregate. And there's a function. There's also a grouping. And then there's also what's called display fields. Display fields are columns or fields that you're not doing any work against. It'll make more sense if I start running some aggregates and show you guys what it actually does. The very first aggregate almost everybody uses is count. What does count do? Count counts the number of rows that are returned by the query. So since we know there's 10,000 and change customers in the ThinkCube database, and it helps if I'm actually connecting to the right database. There it is. 10,000 rows and change. So this is the exact same thing that normally would come out in the bottom if I just did a select star down here, where you see one row 75 milliseconds. Normally it'd come back, 10,000 rows returned. That's what count does. I'm going to turn it around and go to orders. And we got 47,200 and whatever orders. These are common. This is a common aggregate. People use it a lot to figure out whether or not how many rows are being returned. So let's say you got a really complex query that's going to take a while to return. Some people will run a count first to figure out how big the set's going to be, so they can warn the person, by the way, this is going to return like 1 million rows. You sure you want to do this? That's one of the uses for it. Now, what I'm going to do is I'm going to add the customer ID on here from orders. Now, orders has a customer ID. Why? Because an order belongs to a customer. Then it's connected via the ID of the customer, customer ID. I'm going to hit go. Now I'm going to get an error message. Totally intentional, by the way, this one. Column orders.customerID must appear in the GroupBy clause or use an aggregate function. This is one of the reasons why years ago I switched this course away from MySQL and go to Postgres. Because in MySQL, you're allowed to do that. And it becomes totally invalid data. Instantly, it's totally invalid. Why? It picks the very first customer ID and adds everything up to it. So since there's 47,000 orders, customer ID, whatever, 2 would have 47,000 orders. Totally useless information. It's not at all useful. So what it's telling me is that if I'm going to display a column, I have to have it in the GroupBy clause. All right, so here's what we got now. Now we're getting something that looks like real numbers. We have customer ID and a number next to it. The number next to the customer ID says, for example, customer ID 3,565 placed 9 orders. That's what GroupBy does. For every column you want to display and not do math on, you have to include it in the GroupBy. When I start doing more joins in a minute, you'll see where this comes in and it becomes more and more of an, a thing you need to do. I'm going to change this to order lines. Same query. All right, this one took a little longer, and it returned 43,000 rows. And what we've got here is a magic set of numbers. It says, for each of these orders, this is how many order lines are in each order. So you can see there's 3, there's 2, there's 1. So that's how many orders are per. Now there's a few other pieces of information we can do. Instead of using a count, there's another function called sum. Now sum requires you to use it against a numeric column. Why? What happens when you sum up numbers? You get a bigger number. Can you sum up letters? And I don't mean in hexadecimal. Can you sum M plus Z? No. So I'm going to sum up the quantity. And I did 2 separate columns. What I just did is I said, okay, give me a list by order ID. Add up how many items are in the order, regardless of how many of each item there are, but tell me how many items in this order. So how many things are we going to shove into a box? And at the same time, give me the total of the order. So that's what sum does. It's kind of a handy function. In other words, it lets you add up totals. Now there are a few others you can use. There's min, which gives you the minimum value. Max, which gives you the maximum value. There's also one called AVG, which gives you the average. So the average of the numbers. So let's say I decided I want to know what the average quantity is. The average quantity is 2.99. Do we know what it is? What the actual quantities are? No, but what it does just like you would do your average when you're figuring out on your own. You add up everything and divide it by the total. I'm going to go back to here. We can add more columns to this, and the more columns you add in, the more broken down it gets. In other words, for every display column you have, it'll do a total per display column. That means the more columns you add, the less totaling it does, the more detail you get per. Essentially, aggregates are used for operating, for doing math. So when you look up a list of orders, and you want to know how many orders were placed during a certain time frame, and you want to know what the total sale was for that time, you can run that. And there's a few other bits and pieces that are important when you talk about aggregates. But essentially, when you think about aggregates, this is it. That's all there is to it. Really, you sum up something, you add up something, you find an average, you find the min, you find the max. By the way, you can do min and max on letters. So you can figure out what the biggest, the most alphabetically tall name is, high name is. So, anybody who comes in with a ZW would definitely be greater than somebody whose first name starts with a AA. So, that's an example of min, max in letters. There is one thing you cannot do. And you cannot aggregate an aggregate. Everybody has that same reaction. You cannot aggregate an aggregate. This is something I teach when I teach subqueries, which is, maybe today. When you do an aggregate, let's say you summed up all the extended prices as we did right here, right? See, there's a big list going down the side. Now we want to know what is the average extended price. So we added up all the extended prices. Now we want to know last month, what was the average for last month? So maybe we had everything going from $100 to $10,000, but we want to know what the average sale was, total sale for the month was. You can't do it this way. For example, some people will try to write something like this. Which is an aggregate on the aggregate. What do you get? Aggregate function calls cannot be nested. It's a nice English way of saying you can't aggregate an aggregate. There is a way of doing this. You need something called a subquery to achieve it. And I'll show you guys that later. But that is one of the cardinal rules of aggregates. You cannot aggregate an aggregate. Really? All right. So far you've seen this, and I'm going to rerun this one more time. Okay. Now, the other thing we can look at in here also is there is one more clause we can play with. Now, you guys have seen the where clause. You've been working on Lab 7, apparently. Cheryl says Lab 7 is going fairly reasonably well. There is, and actually, if I remember it, I don't even have a single one of these in any of the labs. But you guys know what a where clause does, right? Where filters your results. So in other words, before you do anything else or display anything, restrict it to this set of criteria. There is a way of doing the same thing with your aggregates. And it's called the having clause. Having happens after the GroupBy. It goes down here. Now, you guys are used to seeing, the where clause here. Ignore 1 equals 1. I just want to put a where clause there for placing purposes. And one's always equal to 1, so it's always going to evaluate as true. It's just a cheat to have the word where in there so you understand what's happening. The having clause, the way it works is as follows. it'll select what it needs from order lines, where, now we've filtered out a pile of stuff that we don't want. We do the grouping, and after it's done all the grouping, we can filter on the results of the grouping. So let's say we want to have only orders that have more than 5 things in it. So I can go and now you can see there's no more 5s or less than 5, 6 and up only. So what happens is it takes all the numbers, does all the math. After it's done the math, it looks at the results and then gets rid of anything you told it that you don't want, or it gives you everything only what you've asked for. So in this case, anything that is quantities greater than 5. And on here, I can also go so I want only quantities greater than 5 and extended price more than 500, the sum of the totals, and now we get the larger orders, the big spenders. We could flip it around and play with these numbers to our content, but that's what the halving clause does. You can do all kinds of nifty things with the halving clause, but it's a great way to reduce the numbers that you're looking at, because often in business, and I don't know if any of you have ever dealt with a sales manager. I'm not talking about the person managing the floor. I'm talking about the regional manager that worries only about the numbers, right? If you've ever worked at Tim Hortons, you hear about all the time how they're not selling enough shitty donuts. Or if they work at Subway, suddenly, the fake chicken's not selling as well as it used to because, a report came out that was 80% tofu because it's not really chicken. Just putting it out there. But, and then these numbers aren't working right. So the regional managers want full numbers, but they want to exclude the outliers. Or maybe they want to exclude the ones that sell the best because they know, a BMT from Subway sells, they sell 100 of those a day, 200 of those a day. The sweet onion chicken teriyaki, who knows how many they sell those a day. And you can use the halving clause to reduce how much is coming back. So you're filtering the results of the aggregate. So once you've done up all the math, you use the halving clause to basically get rid of stuff that doesn't apply. So let's just say we only want to know people that bought big ticket items. So the quantity is less than 5, but the extended price is more than 500. That means, on average, each of those items that I would order are slightly more expensive than the other ones where if I turn this around and said the quantity is greater than 10, there's 12 of these, it's still only $500. So that each of those things sold for, significantly less than the ones that were selling 4 for the same price. The 4 for the same price are selling for $180 a pop. Those are probably selling for $80 a pop. $70 a pop, whatever the number would be. And that's how you use an aggregate. Now, you can do arithmetic on your aggregates, which is kind of cool, if ever you want to find out something. We can do some math like that. The extended price divided by the quantity, technically that's the average price per unit. That's not the average extended price, that's the average price per unit in that order. Right, so how much was the order total divided by how many things we sold? Who cares how much each of the individual things cost? But what is the average price per unit? So these are all things you can do with aggregates. This is all stuff you can do with basic arithmetic. By the way, you can do all the usual stuff in here. Divide, subtract, multiply, add. So all the basic arithmetic ones there are there. Postgres gives you lots and lots of math operators. Pretty much anything you can type into a scientific calculator, you can punch into this and Postgres will figure it out for you. If you can figure out the appropriate notation to put it in, but it can do it. Other aggregate functions that you'll see, mean, which is, the median. Anybody here ever study statistics? Yeah, it's got all the stat functions, standard deviations, everything's there. So if you know how to do stats and you want to play with numbers, Postgres has all of your standard statistics functions are there. Just so you know. And so if you like doing stats and you like shoving stuff into a database, you can use your database to do your stats work for you. Oh yeah, for the function. And if you're not sure what the functions are called, that's the basic set of aggregate functions you have. Some of them are really strange, like some of these are for programming purposes. This is for web development. There's min, max, sum, but there's your stats ones. Correlated coefficients, correlated covariances, you know. Standard deviation, your standard variations. Ordered sets, percentiles. The people that like working with percentiles. You can do percentile groups, so you can break it down by percentiles. Hypothetical sets, whatever the heck that is, that's new, by the way. That wasn't there last time I taught this course, so this showed up recently. And you got the usual grouping. They've got one called roll up, which allows you to actually roll things up instead of rolling it down. It's got tons and tons of this. So if you really want to learn how to use all the aggregates in Postgres, you're going to spend an awful lot of time experimenting. I usually learn them as I need them. So min, max, sum, and average are the ones I use the most. That's because those are the ones you see most in business. Okay, any questions about aggregate functions? Going once, going twice. Sold. Okay. Now I'm just going to take this query. Where the heck did that go? I just don't want to lose it. Now, what I'm going to talk about next is joins. We've already seen joins last week. I showed you guys a join last week. So you guys know what an inner join is. Now I'm going to talk about the other ones, the left and the right joins. So far I'm building this up. This isn't anything you haven't seen yet. Perfect. All right, so I'm going to explain left join and right join. And essentially, I'm going to actually break this down so that in a slightly different order than I normally type it up on the screen. So what I've said is select everything from products, left join product versions, on, and then the usual criteria. Now, the difference between regular join, see there's let me do regular join first. 100 rows. I'm going to do the left join, 108 rows. Now, the logical sense is that we've got more data coming back. Why do we have more data coming back? What left and right join means is select everything from products, left join product versions. So it's saying, give me everything to the left of the word join and any possible matches to the right of the word join. And if I scroll down, you'll see right here, so this is the product right here, right? ID, name, and active. This ID product version, this is coming from product versions. If I scroll right to the end, you'll see suddenly that there's nulls in this column. Why? Because these products have never been given a product version. So the products, those, whatever that is, 4 or 5 products that are in the products table don't exist in product versions. In other words, it's never been assigned a version. Therefore, it's never been sold. And that is the difference. That's what a left join does. It lets you find stuff that hasn't sold. Now, what is this useful? So let's back up for just 1 second. If that's the left join, if I do a right join, it'll do the exact same thing, except it'll give me everything to the right of the word join. So it would give me everything in here with anything that matches from here, and if it doesn't find equal matches, then it returns nulls for it. So down here, we have nulls. And what would you use this stuff for? There's usually a lot of people ask, well, why do you need a left join and a right join? Often it's used to find records that are missing, or you're trying to find or dead records or orphaned records. One good example of this would be, let's say you're a store that has a huge product catalog. I'm not even going to use Amazon because theirs is absurd. But let's go with Sears. As successful as Sears isn't anymore. But Sears, for example, had this huge product catalog. And what they'd have to do every once in a while is they go, give me all the products that haven't sold anything in the last 6 months. Then they'd run it. And if nothing is sold in the last 6 months, maybe it's something they don't need to keep in stock anymore. Therefore, take it out of the catalog, take it out of the ordering, put a clearance on it, get rid of the inventory, and we're done with it. That's what you'd use the left join for. So you can find things that haven't sold in a time frame. So if I were to do select star from order lines, where, so from products, left join order lines, and where there's a certain, say, a time frame of 6 months. Therefore, it'll give you all the products that sold in the last 6 months plus all the products that didn't sell in the last 6 months. At that point, it's still a lot of noise. So you can do a little technique like this, and this is not a technique that you need to know. Yes, you do. Like, you really need to know this probably for a test or a quiz or an assignment or a practical. There might be a question, because some of this stuff is random, so you may end up with a question that says, how many of this didn't sell? Or how many products have never been sold? And how would you figure that out? You'd do a left join, just like this. Except what you'd do is you'd go, now that looks kind of odd. But if I run this, now we have the 8 rows of the products that were never given a product version. Why does this work? It's because, well, I'm going to take this off and rerun it. As you can see right here, ID column here has a value all the way down until you hit the last set. Whenever you do a left join, any table that is part of the left join that has no matching data returns a null row. So an entire row of null values. Therefore, since it returns, I hate using the word a value because null is not a value, but since it returns an absence of value, you can check for that. You can say, oh, we need to know which ones have never been given a version. Therefore, let's go look for where the product version ID is null. That means this product was never been assigned to a product version. And then we run it. We have 8 products. What's in these 8 products? Products that have been sold. Because if it doesn't have a product version, that means we never sold it because we can't sell unless it has a product version and an MSRP. Therefore, these are dead products. Or maybe they're new products that haven't been given versions yet. Maybe they're trying to find out which products that have been designed are sitting out there on the shelves and they never thought of selling yet. That maybe these are the ones we need to start selling. Who knows? There's some websites that are entertaining to do that with. If you go to Eurocom's website and you look at how the URL is set up at the top, you can start messing with it. There's numbers up there, and you can start incrementing the numbers. You can see which laptops are about to start selling. Because they define all their future products and they don't actually take the time to clean them, lock them off the website. It's entertaining, looking at what they might be offering in 6 months. But these are products that are coming down the pipe. They didn't bother to exclude it. This allows you to find things that are out in the open. That's what left and right join does. The right join is the exact same thing as left join, just flipped to the other way. And if I really wanted to show you guys what it does, I can take this. Okay, now if I do this, I get nothing. Because now it's going to try to give me everything in product versions and any matches that aren't here. I can turn around and do a right join. And now, here's our products now on the right side. Because I flipped them, I can show you guys what the right join does, which is the exact same thing, but it's everything to the right of the word join instead of everything to the left of the word join. And you got to take into account it compounds, right, as you go down. If you have multiple join statements, when you have a left join down here, it assumes everything above it to the left, not just, the one previous. It's everything to the left of that join statement. So everything above it has to be there, or everything below it has to be there, depending if it's a left or a right join. You will get to practice this stuff on one of the labs, just so you know. Okay. Those are the three big joins. There's an inner join, which is also known just as the regular join. Left join, right join. Those are the three big ones that people use. There's also the set operators, which I'm going to talk about quickly. I just got to switch databases for that one. I hope I have everything I need. Actually, I don't know if I need to switch databases. Hold on. Oh, I don't. I already did the prep. Okay. This is parts of Lab 8. Literally, I'm going to show you guys like the last three answers of Lab 8. Why? It's the only way to do them in demonstration, so. Okay, do you guys know what a set operation is? I'm not talking about math, database ones. I'm talking about math. Yeah, anybody here ever work with sets? So there's three operators you normally find on sets. What are the three set operators you normally find? Do you remember what they are? No, not database. Math. In math, there's three common set operators. Union, which is the same as the database ones, by the way. Intersect. And then the last one has two different names. It's either known as an except or a minus. So those are the three common set operators, and I'm going to show you guys what they do in a second. However, the way set operators work is you take the results of one query, you tell it what the set operator is, then it takes the results of a second query, and then does the magic set math, I guess you call it. Now, I'll show you like this. So, you've seen customers have email addresses. There's also a table called trade show leads. All right. Trade show leads also has an email address. Now, the very first one we have is union, and I need to get my markers out. Okay, you guys know what a Venn diagram is, right? All right, so the union is where the two sets overlap. That is a union. And I'm going to run, actually I'm lying, that's the intersect. Damn it, Jim. Okay, that's not the union, that's the intersect. I hate Venn diagrams. Unions and it looks like it's everything that's in there. However, what union does is it returns only the unique values from the two sets. So if I were to go, and this one here we got to run a little bit of, I just got to run math for a second here. So we've got, in one table, we know we have like that. And in the second one, we have right, so 11,429 email addresses total. However, if I do the union, we end up with 10,964. Now, you get 10,964 back because there is an overlap of about about 1,000, no, not quite 1,000, 800. So you got an overlap of roughly 800. That means that there's 800 email addresses in trade show leads that's also in customers. So this is the kind of technique you'd use, and we use this one at work because we have a very large customer database. So we have customers from around the world. But sometimes we want to send out a mailer to not just the customers, but to our leads. These are potential customers, people that approached us at trade shows or have registered on our website for more information when they never bought anything from us yet. So we'll send out a promotion saying, oh, we're selling SignLab print and cut for $500 off for Black Friday. Yay. And so what we'll do is we'll send it out, but problem is that sometimes we have somebody that registers on the website that is already a customer in our system, but they wanted information about the next version coming out, right? So they're running, say, SignLab 9.1. SignLab 10 just came out. They want to know what SignLab 10 has. So they register on the website, download a demo of 10, try it out, go, oh, it's worth the money. No, it's not worth the money. So by law, we're technically, even though we're spamming American customers, so who cares? But by law in Canada, we're not supposed to send the same email to the same person twice within the same mailer. If we send the same mailer twice over 2 weeks, that's okay. But you're not supposed to send it to them twice in one mailer. So what we'll do is we'll go select email from customers, union, email from leads, and it gives me a clean list of just the unique email addresses from both bins. That's what you use union for. Well, not just that, but this is the easiest example of union. Now for intersect, which I preemptively drew. Let's just say we want to know which ones are here. I just want to know the email addresses that exist in both. So maybe because they're already in our customers. So let's say A is customers and B is leads. We want to know the ones that overlap so we can get rid of them out of leads because they've already given us money. Or maybe we want to send a mailer out to just those people that have registered recently for one of our demos. And we want to target just them. So the command's called intersect. 459 rows. So by the way, when we were busy trying to calculate that number, that's the number. 459 rows. That means there's 459 rows that exist in both tables. Good. The last one is except. So blue is union, Red is intersect. Except means give me everything from bin A except any you might find in bin B. So that will exclude everything in bin B, including the overlap. So anything it finds in this overlap will not be included, and obviously anything that's unique to B won't be included also. It'll only give you the unique records from A that don't exist at all in B. And now we got 9,635, which is essentially 10,100 minus 400 and whatever, or 459, whatever that magic number was. So that's except. Those are the three set operators that you find in most database servers, except for MySQL. MySQL gives you union, and you're supposed to be thankful to give you union and only union. If I want to do one of those, if I want to do an except or an intersect, I can't do that in MySQL. I have to do it a different way, which is less efficient. A few caveats of using set operations. I'm going to go back to union. I'm going to throw in the word name. Now, what's the difference between the first query and the second query? The second one has less columns. What's the error message say? Each union query must have the same number of columns. What they don't tell you, it should also have the same data type. In other words, it's like trying to compare a room where there's, where there's certain attribute, where, I'm trying to find a real world example of this. It's really hard. But essentially, you can't compare two different, actually, you can use comparing two different kinds of citrus, right? You know the whole thing, you can't compare apples to oranges because, they're not the same thing. If you don't have the same number of columns, at this point, you're not comparing comparable pieces of information, comparing two different sets of information. So one has less information than the other, so you can't do a proper comparison. That means they can't do the proper set operation on it because it doesn't have the right pieces for it to figure it out. Computers are smart, they're not that smart. It's not like it's going to say, oh, you're retrieving email from two places, we'll just ignore a name. You can't do that. If you're going to use a set operator, such as union, except, or intersect, you have to have the same number of columns. That's, yep. What does it say now? Union type, character varying, and integer cannot be matched. Now I can do it. And what do I get? 11,429. Why? Because we're including all the names and a bunch of A's out of the second one, which at this point becomes completely useless because we might have just done, select everything from one, then select everything from the other and just run with that. The more columns you put in, the more distinction there is between each set. And the more distinction there is between each set, the fewer matches it's going to get. So when you want to do unions, you want to reduce the amount that you're retrieving as much as possible so that you're working with clean data sets. You've seen this pattern already when I tell you guys don't retrieve star for everything because it's going to eat so much of your bandwidth. In this case, the more data you include in your union, the less precise the query is going to be. That's just life. Now there's one other operator which is totally useless, and I don't know why they existed. They exist. Union all. What do we get? All of them. No, union. No, it's not the same number. Union has 10,964. Union null gives us 11,429. It just gives you a copy of everything it finds. That's the difference between union and union null. I honestly don't know what the purpose of union null is. There's just somebody came up with it and said, "Oh, we should include it because somebody will want it." That's okay. Okay, those are set operations. We have, what time is it? I have time to do it. Okay. I can push for 20 more minutes and we'll be done almost everything, except I'll do one everything in example. Well, minus set operations. That's just getting asked for too much. The next thing we got to talk about is subqueries. So you've seen a join where I take one table connected to another table and get results. You've seen a union where I take one query and then do matching against a different query and ask it to either give me things that match, give me things that don't match, give me the things that are in one but not the other. There's something called a subquery. And you can think of it almost like query inception. And by now everybody's seen the movie Inception. Or almost everybody's seen the movie Inception. Well, actually, it might be far gone now that actually I might have hit people that haven't seen the movie Inception. But anyways, essentially what happens with a subquery is it's a query that's run as part of another query. It sounds like a terrible piece of English, but here's an example of a subquery. And it's actually a really stupid subquery because I could do this with a join just as well. So what it does is it resolves this query first, takes the results, turns them into a list, and then operates it on the second query. And if I run the explain, this look command here, it gives you a diagram of what just happened inside the database server. If ever you're curious what your queries are doing, it's this icon right there where I put my mouse cursor. It's called explain. Explain's kind of cool. When you start getting things get complicated, which they will in a minute, and I'll show you guys. But what it just did is it took everything from products and built a hash out of it. Now, if you don't know what it, you guys have you learned about arrays yet? In Java? Maybe, kind of, but not quite. Arrays? No? Okay. Still no. If you were learning in Python, you know about them by now. So, okay, a hash is like a list. An array is a list of values that's contained in one bin. It's like a table unto itself. So what it's doing is it looks the results of products, it grabs all the IDs from products, and basically builds a list in memory of the results. Then it does select everything from product versions where the product ID is in this list, which is what this just does right here. So it builds all the products, prepares a hash, grabs all the product versions, and then it figures out what the overlap is between them. So that's what that does inside itself. That's a subquery. So essentially it executes this query first, grabs the results and passes it to the query on the outside. That is subquery type number 1. This is the most commonly used type of subquery. There are uses for this. Usually it's when you have tables that don't have proper relationships, where you end up with weird connections because you're working with crappy old data. When I first finished school, I thought subqueries were the bomb because I hated doing joins. I used subqueries for everything. And then I discovered the performance penalty of using subqueries because they get expensive after a while. When you start nesting subqueries, because you have a subquery inside of a subquery inside of a subquery instead of a subquery. And the problem is that each of those gets run for the number of times it's nested. So if it's a subquery nested 3 times, so there's 10 rows being returned with 1, the next one returns 10, the one returns 10, the one inside gets run to 10 times the power of 10. That's an awful lot of queries being run. So 10 times 10 times 10. So the inner query ends up getting run 1,000 times, theoretically. And if you keep running the same query over 1,000 times, yeah, that server gets clever and it starts caching the results, but you're still asking for the same thing over and over and over again. And it's gross. Now, that is method number 1. That's just a standard subquery that you'll always see. Now, remember earlier when I said I'm going to teach you guys how to figure out your aggregates? How to average your aggregates? Watch this. I'm going to go grab my query I wrote earlier. Yeah. So I've got this. I'm actually going to get rid of the having clause, just to keep this a little bit cleaner up on the screen. I'm going to get rid of my where clause because I'm trying to reduce how much is being returned here. Okay. Now, there's another kind of subquery, and it's known as a derived table. And it's a very common use for when you're dealing with complex aggregates. So remember earlier when I tried to do the average of the sum and I couldn't do it? You can. But you have to do a query inside a query to achieve it, and that's what the demonstration is going to be. The first thing I got to do, though, is I have to give it aliases. Like such. All right, so I got myself some nice labels. Actually, I'm going to take this off first so you can see the error message. I'm a big believer in showing you error messages so you know what those error messages mean. I'm going to hit run. Subquery in from must have an alias. You have to give it a name. Otherwise, it doesn't know what to do. And I'm going to run this. Looks exactly the same, except you notice it took twice as long to run. No, actually, it took just as long this time. I don't know why, but it's taking forever. Now, just a little bit longer when I do it this way. So now you're thinking, well, what's the use of what you just did? You're just basically running a query on top of a query, not actually doing anything yet. Let's ignore order ID. But we want to go now, notice I'm actually referring to the alias of the column, not the aggregate function. Because once you've done this, this temporarily becomes a table. It becomes a table in memory temporarily with those column names. That means for the lifetime of this query, this is a perfectly valid name for that column. And here's our average order total. Remember earlier I said, if you wanted to know what the average order total was, you can't do it by can't go do an aggregate in aggregate because the aggregate functionality happens only once. And same thing here. I can go I can also ask it, what is the average number of items per basket? These numbers have absolutely no relation to each other when you think about it, because they took all the order totals, added them up, divided them by number of rows returned, then they took the total number of items in the baskets, divided by that number of rows returned. They have no real world, whatever you want to call it, to each other, but they're both completely valid stats as far as management's concerned. You can also turn around, and this is what's kind of cool with this. So now suddenly I can retrieve a list that says, oh, the total quantity. So the biggest order had 40 things in it. The biggest order total was 2,923 and change. Those are the biggest order total. That's the most items in the basket. And that gives you, and then the averages are in the middle. It doesn't make a difference. You can run as many aggregates you want in one go. It'll do the math for you. And I'm going to run the explain on this. And as you can see, it's actually a straight line thing. It goes, it's going to do the order lines, it's going to sort, it's going to create an aggregate, it's going to create a second aggregate, and then math. So it does, it grabs everything from order lines, it sorts it so it's organized properly. It does the inner aggregate, and then it does the outer aggregate. And it gives us this. And as you can see, it's fairly quick, 158 milliseconds. And if I were to keep running it, actually it's probably peaked already. Yeah, so 160 give or take 10 milliseconds. And now I'm going to give you the all-in-one example. Because so far you've seen subqueries, you've seen joins, you've seen all kinds of stuff. Now we're going to do some math, and I'm going to do some joins. I'm going to show you guys a complex set of query, one complex query that shows a bit of all the techniques you've seen today. And yet last week. And I'm making it up as I go here, so because I don't have a pre-planned one in my head. But let's say I want to know, broken down by province, what the average sale was. Average order total. Now we got to think about this, right? How do we figure this out? Because, you know, there's an awful lot of bits and pieces we need to retrieve out of this. So first things first, we probably want to go because I said, okay, well, we're going to do it broken down by state province. Okay. Well, now we need to know what the customers are. All right, so this is getting longer and longer. So now we have what the state province could be and what the customer is. So we're going to reduce the data set a little bit because I don't care what the name of the customers are. I just care about what state or province they're in. But while I'm at it, I'm just going to call it state for now. All right, so now we've got at least a country and a state. Of course, customers have orders. And as you can see, the order here is not that important between the order after the on clause isn't that important. You can go whichever order you want. Okay, so far you've seen me drill all the way down from the state province all the way down to the order lines. So this will retrieve lots and lots of data. That's how long that's going to take to run. So 114,000 rows of data. And It is significantly a significant amount of data, but we're not actually doing anything useful with it yet. Now what we can do is go I'm going to put this on another line. Now we're going to get an error. Obviously we're going to get an error because I just threw in some aggregates and I don't have a GroupBy clause yet. I'm going to make this just a hair smaller so that I have a little more screen room here. So now, we are going to find out, we have it broken down by country, by state, and by order, and what the totals are for each of those items. Which we should give these nice names. I'm actually going to post this example right on Blackboard. So it's getting bigger and bigger as we go, right? Now, we sort of have useful information now. We know that in Antwerp, Belgium, you know, there was a bunch of orders replaced, and that's how much each item was in there. I'm going to add a where clause in here. Because I just want the Canadian ones. And now we're retrieving only 6,000 rows instead of 110,000 rows, or whatever it was. Since we know that, I'm going to take the countries out of here. Like this. All right. So now we have province, an order ID, and some totals. But let's say we want to have totals per province. We could take the order ID out, and it would just give me my total per province, which would be fairly valid data, but we still don't have our averages or anything like that, like the sales managers would want to have. So what do? You're going to throw this inside of a derived table. So that's just a name. You have to give it a name of a table. So I called it summed data. And it should give us the exact same result because we're not doing anything with it yet. Now we could go from state, comma, and now we have 13 rows returned. Why? Because there's 13 provinces and or territories in Canada. And we have our total, the average number of things per basket, and what the average order total was per. Now these are really brutal numbers to look at, and I'm going to show you guys how to fix this in a second. But, and like I said, I'm going to actually clean this up in a minute so it actually is, then when I post the Blackboard, it's actually going to be pretty. Now the only other thing really you need to make this a little easier to work with, and this is a function call you'll want to know, because it's going to be really handy when it's time to do the practical test. Because often I ask you to round numbers. You know, give me this number rounded to 2 decimal places. And did you know half of people out there don't know how to round numbers properly? What happens when the number is 5? Does it round up? Does it round down? 5 goes up. Well, let's say it's 4.55. Round it to no decimal places. It'll go to 5. 4.55 goes to 5. If I tell you to round it to one place, it'll be 4.6. But if it's 4.54, it'll be 4.5. So that's what rounding does. Now, round is not, just so you know, round is not an aggregate function. You can use it anywhere. It's a mathematical function. There's tons of mathematical functions. Round rounds it. What's the second argument? Comma 2 means rounded to? Yes. So we do round. And now you're not going to give your manager a stroke. Because they're nice, simple numbers. Managers understand these numbers. They're rounded properly. That means, believe it or not, what it was actually displaying for you in that column was actually truncated. It's actually working at a level of a float. So when it's hitting an irregular number where, 7.66666666 ad infinitum or 0.33333 because it cannot, the number never ends, it'll actually display like 10 digits and then round it. But you could actually ask it for more than that. And it'll keep going as long as you ask it to. Or you could just round it like this and it gives you nice numbers. Like such. Now, this is an example that shows you everything that you need to know about SQL in one go. What do you have in here? You have joins. You have a where clause. You have aggregates. You have a derived table. You have a mathematical operator. An example of everything's there. Literally in this one query. It is the only thing I have not thrown in here is a having clause, and I'm going to throw in here just for argument's sake. Apparently, the big spenders are Northwest Territories, Nunavut, and the Yukon. Actually, it's really funny because that also matches out where the prices are most expensive in Canada. It's actually completely fluke that it worked out. Because Nova Scotia, New Brunswick, Nunavut, Northwest Territories, Saskatchewan tend to be where some of the highest prices for stuff is in Canada. Newfoundland didn't get included for the ride. They must have been talking about beer prices. But that's an example of everything. So I'm going to take this query. I'm going to run it through a little tool that I have that's going to clean up the syntax so it's nice and clearly laid out for you guys. And I'm going to post it to Blackboard for you guys. Yes? Yep. The recording is up. It is up. It is up. And I didn't post any examples from last week, but this week I'm putting this one up because, like I said, it's got some of everything in it. This one query shows you everything you need to know how to use to do Lab 8, Test 2. No, not Test 2, Assignment 2, and most of the practical. The lab will give you everything else you need for the practical. So this practical test, also known as an exam. But I'm not allowed to use the word exam. Why? Because exams are canceled. Yeah, I'm going to explain it better later, but essentially, it's somewhere between, it's actually very similar to Assignment 2. So you get to do Assignment 2, and then the practical is very similar to that. So Assignment 2 has a series of questions. It'll say, then it uses the ThinkCube database. So it'll say, how many of this are there? How many products did not sell? Or what is the orphan this or that? And then it gives you a slot and you type in an answer. When you hit submit, you know right away how well you did on that part of the assignment. Same thing with the practical test, except the difference between the practical test and the assignment is the assignment, everybody gets the same questions in the group. So you all have the exact same assignment. So if you don't know how to do something, you can talk to the person next to you and try to work it out as a group. You're not submitting as a group, but you can try to work it out with your friends. When is the practical test? It's randomized. So you could have 5 people sitting next to each other and not one of them have the same test. They'll have overlapping questions, but they'll be in a different order. So going, what's the answer to 5 is totally useless. Or if you do, like I once saw during an exam, And then I'm listening, and the other guy behind was going like tap, 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 or tap, 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 saying answer number 3. Well, I watched this for 10 whole minutes. I'm like, man, you guys spent so much time coordinating. And what you guys don't realize, we were running an A-B exam that time. I don't know if you know what an A-B exam is. Rows of exams down the chairs, right? A, B, A, B, A, B. The guys didn't know they didn't have the same exam. Guess which one didn't do very well? It was hilarious. So the practical test is like that, where it's a randomized set of questions. It's only 10 questions. So you need to write 10 SQL questions, and the way it's set up is there's 2 easy questions, like, you know, like literally select count from this kind of thing, you know, nothing too fancy required. There's 7 medium questions, which require you probably do a join or run an aggregate, you know, with a where clause kind of thing, you know, how many orders are in Ontario kind of question. Then there's one more question at the end, the hard question. No, that's even past the hard question. Like, I wouldn't ask you to write that during a test. You haven't done SQL long enough to try that. But the hard question is the differentiation between basically an A and an A+. Essentially, since out of 10, each question is worth 1 point because there's only one possible answer for any given question. Well, actually, no, even that, you can still get 9 and not get the last one. So if you even get 9 of them, the first 9 right, you still end up with an A+ because it's 90. It'll say, how many of this are there rounded? What's the average price of this? Rounded to 2 decimal places, and you type in the numbers. I don't care what SQL you did to do it. You use whatever technique works for you. I want to have the answer. Because, you know, when you go out in the real world and you get a job, I can guarantee my boss does not give a shit how I give him I get the answer. He just wants to know the answer. I'm treating the practical examination or practical test the exact same way. I don't care what technique you use. Every given question, there's at least 3 ways of solving it to get to the same answer. And then there's one year where a student shocked me and he came up with a totally different method of doing the whole thing. The guy was an Excel wizard. He was a trained Excel trainer, a Microsoft Office trainer. Like, he had every certification for Office you could ever ask for. He knew every function in Excel inside and out backwards. He exported the entire database to Excel. And he got 10 out of 10. He did it all in Excel, and he showed it to me after he was done. This is how I did it. He says, "This is okay. Go frig, you give me the right answers." Apparently, you understood how all the data was interrelated. Therefore, you understood the concepts of how the data was connected. Apparently, SQL is not your thing. But it was. He was fine with it. He just so stressed that he didn't want to think about SQL, so he brought it into what he's comfortable with. I'm like, that's really not the way I'm supposed to do this, but what else am I supposed to say? You got the right answers. And since it was randomized, the other thing you're going to get is next week I'm going to release the practice practical to you guys, which is my old practical exam, the one where I was told was not fair. It was brutally hard. But it was a take-home exam. You had 5 days to do it. There's only 21 questions. But apparently it could take from 3 hours to 18 hours depending on your skill level. Yep, you're going to sit at your desk. You're going to come into this room, turn on your laptop, open up the test, make sure you have the appropriate database loaded. I'm giving it to you guys a week ahead of time because it's not ThinkCube you're working with for that practical. Part of the practical, and I was told even that was too harsh. I like testing my students appropriately. Originally, part of the practical was I would give you a database. You had no idea what it looked like before the test. You were given a database. You had to restore it into your database server, and you were given a diagram. The diagram showed you what was inside that database, the structure of the database. And you had to figure out, without coming in cold, how to write your queries, which is a very good test of your skills. Well, it's true. Do you understand the database theory behind what the database diagram is telling you? Yes or no? Are you able to write queries in a cold environment? Yes or no? Those are valid questions and tests, but I was told that was too hard. It is hard. You get an assignment that's almost identical. You get a practice practical that's almost identical. I give you guys lots of practice beforehand. Coming in cold, but if you're not coming in cold, you're going to be given the diagram in the database a week ahead of time, so it's set up on your machines. So you have a chance to explore the data. I actually had a student that tried to, after my practice practical, and after the labs, he decided to start writing extra questions for himself, and he actually wrote questions, and he says he tried to answer these questions himself ahead of time. So he'd actually create questions, and then he'd try to figure out the answers, which is kind of cool. And that's how he practiced for the exam. And he did well. He got one wrong because apparently he didn't understand the meaning of a comma. One of the questions has a comma that specifies something important. He stopped reading at the comma. So he didn't actually do the question right at all. It's not that he typed it in wrong. He just didn't do it right at all. So, yeah. Yep. Assignment 2 has, oh, yeah, I'm going to go show you guys that. Okay, assignment 2 is live. Now, there's two things here. You'll see. There's assignment 2 part 1. I don't care if you use Toad. You can use any diagramming software you want. You can even do it on paper. I don't care. Do it on paper, take a picture, and upload it. I don't care. I've given you a broken database. And I've actually had databases coming from students that looked like this submitted as assignments. So that's somebody who wasn't paying attention to what I said in class. And as you can see, you know, I'm a bit sarcastic on that one. You've been handed a diagram by a junior developer. Apparently he wasn't paying attention in his introductory database class because he botched it. I'm giving you 3 tables, and it's up to you to figure out how to fix them. Right? So this is a generalized application of everything you should know by now. You should try to figure out what the relationships are between the tables. You should fix the naming conventions. You should look at the data types and make sure you're picking appropriate data types. So that's what you're being graded on. So how well normalized the data is the design? Is it properly diagrammed, in other words? They may not need to be normalized much more than that. But is it, you know, did you actually, while you fixed it, did you break something else? That's what I'm checking. The proper diagramming and structure, including naming conventions, relationship, and anything else. I'm even going to give you guys a free point for naming the file properly. You name the file properly, you get 1 point. Okay? And people laugh when I say that because you know what? You know how many people did not name their assignment 1 properly? Lots. And I wasn't taking points off for not naming your assignment right because it's always my big test on how well people are listening and or reading the instructions. 1 point for naming the file right. You give me the right file name, you get a point for free. And I even put the reminder about the naming conventions because the number of people that lost points on naming conventions is too damn high. Those were free points on the last assignment. And I'd say about a quarter of the group lost points on it. Why? Because they decided not to double check what certain things meant. Okay. Now, that's part 1. The good news is this whole assignment's work by yourself. No group work. That should make people happy. Right? Part 2. Now, I include the ThinkCube database down here just in case somebody's laptop shits the bed this week at some point, or next week, and they just, oh, I got to wipe my laptop. You need the ThinkCube database to do this part of the assignment. It's the same one you have. I'm just giving you a shortcut to here so you don't have to go digging through the lab documents to get it. Probably going to tell me I'm not allowed. Okay, here's what the second part of assignment 2 looks like. How many employees are there? Give me a number. How many customers have their names starting with JA? Watch your case sensitivity. Many customers have their names repeated several times. There are 4 that have the most repetition. Enter one of their names. Pick any. Figure that one out. That's the kind of questions you're going to get. Some of them are a little more complicated than others. So this one has 13 questions. You get a lab period to work on it. I'm going to tell Cheryl she gets a lab period. You guys get a lab period to work on this. Not this week's lab, next week's lab period. Same thing with next week's lecture period. It's for this. So next week is work periods all the way across. So if you come, you come. If you don't, you don't. If you need help, come and have a chat. If you don't understand a question, come and ask. Because this is your preview of what the practical exam is going to look, practical test is going to look like. It's the exact same format. No, you don't get the answers till everybody else is done. No. You have to type it in. There's no multiple guess. That is, considering the base number of questions for the practical, yeah, that'd be a nightmare for me to set up because I'd have to write it in so that it'd be like 20.01, 20.03, 20.02. And then somebody might not pay attention and actually click the wrong one. And they might have had the right answer on their screen. They clicked the wrong one because, they panicked. Therefore, I'd rather you type it in. Careful when you copy paste because sometimes it includes quote marks. And Blackboard's kind of stupid that way where it doesn't like quote marks. But yeah, that's the assignment 2. You have 2 weeks to do it. Realistically, this is somewhere between Lab 7 and Lab 8. So if you're able to get through half of Lab 8, this shouldn't be hard. And you have an entire week to work on it, of class period, class time. Any last questions? Going once? How many marks? What? 10%. 10%. The 2 halves of assignment 2 combined. The lab test is 20%. All of it. Which is actually, because originally there was a final exam and it was a split exam, where 20% was practical, 20% was theory. 20% theory is gone. So you get 20% practical, which you get a practice for, plus an assignment, plus 2 labs that all feed into it. So by the time you come around to do this, the practical test, you should have more than enough practice to achieve it. Basically put, if you can do assignment or even lab, if you can do lab 8 and then you don't do it, you finish it, then you don't look at it for 2-3 days, don't look at your answers and redo it, and you can do it in half the time. You want to aim for lab 8 done in less than an hour, essentially. Or lab 7 plus lab 8 combined in an hour 20 minutes. Considering it's lab 7 is what, 12 tasks and lab 8 is like 16 tasks combined, so it's 30 some odd tasks in both of them. And then what's that? 10 tasks in lab 7 and the other one's like 16 or something. So 26 tasks, the actual practical is 10. So it's actually significantly less. All right. Any other questions? You had a question. It's been answered. All right. Going once, going twice, going 3 times.